Hey kids, today we're on Unit 3, Day 2. We're going to solve two-step equations. If you've got any questions about it in your book, you can reference to section 2.3. We're also going to call this, let me see, SADMEP. That's what we're going to learn today. We're going to learn SADMEP. I'm going to work in PEMDAS backwards in reverse. Let's see what I mean by that. Okay, now you have an equation here, and from the last section, you know if it was just t minus 17 equals 3, you could solve that because you would just use the inverse operation to subtraction, so you'd add 17 to both sides and get your answer. And you know that if it was just 4t equals 3, that you'd use the inverse operation to multiplication, which is division, and you divide both sides by 4, and you get your answer. But life's not that easy. You actually have a complicated expression. So on the left side, so it's 4t minus 17 equals 3. Now the way we're going to work this is we're going to actually kind of unwrap this to isolate t. We're going to use reverse PEMDAS. So you know that PEMDAS looks like this, and when we're simplifying expressions, we go this way. But when we're solving, we're trying to isolate our variable, we're going to go this way. That means that first we're going to handle our addition and subtraction. Then we're going to handle our multiplication and division. And that's as far as we're going to go on this lesson. But let's see. So I see that I'm subtracting 17 from both sides. So what's the inverse to that? Adding 17. Add 17. So I end up with 4t is equal to 20. Great. Now t is almost isolated, but not quite. It's still multiplied by 4. So I'm going to divide by 4, and I end up with t is equal to 5. Now let's check my answer. I'm going to rewrite my equation, and instead, I'm going to do it again, but instead of writing a t, I'm going to put a 5 in there and see what happens. 4 times 5 minus 17 is equal to 3. Now on the left side, I'm going to use PEMDAS because that's how I simplify expressions. So I'm going to do multiplication and division first. So I'm going to get 20 minus 17 is 3. Let me see. 3 equals 3. That is true. That means that, I can box my answer, t is equal to 5. Yes. Okay, that's true. Let's try this one. I've got 6y plus 4 equals negative 14. So I'm working backwards in PEMDAS. I'm going to do my addition and subtraction first. So let's see. Minus 4. So I end up with 6y, and then just plus 0, because that's what I'm going for. I'm trying to get y isolated, equals negative 14 minus 4 is negative 18. Now to isolate y, I've got to do the inverse of multiplying by 6. So I'm going to divide by 6, and I get y is equal to negative 3. Let me check that out and see if that's true. So 6y plus 4 equals negative 14. So I'm saying that 6 times negative 3 plus 4 is equal to negative 14. I don't know. Let me see. So I'm going to do multiplication first. I get negative 18 plus 4 equals negative 14. I'm going to add here. I get negative 14 equals negative 14. Oh, yes, it does. Makes me happy. It means I can box this answer because it is correct. I've solved for y. Y is 3. You try. Don't forget to check your answer. Once you've come up with a statement that's true, that means the solution to that variable is correct. And you can then box your answer. Okay, now let's look at this one. Looks complicated. It's really not. I know that first I'm going to handle my addition and subtraction, and then I'm going to handle my multiplication and division. So first I'm going to handle this, and then I'm going to handle that. Here we go. I want to get rid of 6 on this side because I need to isolate my variable. So I'm going to subtract 6. Subtract 6 from both sides, and I end up with x over 4 is equal to 3. Now I've got x divided by 4. His inverse operation is to multiply by 4. Multiply by 4. And I end up with x is equal to 12. Let's check. Let's see. So you're telling me that x over 4 plus 6 is equal to 9. So I'm going to substitute, instead of x, I'm going to write a 12 and see if this thing holds true. 12 over 4 plus 6 is equal to 9. 12 over 4 is, 3. 3 plus 6 is equal to 9. Keep going here. Is 9 equal to 9? Oh, yes, it is. That means I can box my answer. X is equal to 12. And that's my answer. X is equal to 12. Let's try number 6. Okay, what am I going to do first? Shall I divide first, or should I do my division first? My subtraction first? Yes, I should handle my subtraction first. So what's the inverse of subtraction? Addition. I'm going to end up with x over 5 is equal to 11. What's next? I'm going to have x, I'm dividing by 5. Well, I need to multiply by 5. Multiply both sides by 5. If you want to, you can make that 5 over 1 if that makes you happier. It's up to you. So these are going to divide out, and I'm going to end up with x is equal to 11 times 5 is 55. Let's check it out and see if it's true. So I had x over 5 minus 8 equals 3. So I'm telling you that 55 over 5 minus 8 is equal to 3. Let's see if I'm telling the truth here. 55 over 5 is 11. 11 minus 8 equals 3. Let's keep it going. 11 minus 8, or plus negative 8 if you like, if that's your preference. It gives me 3 equals 3. Oh, that's true. Yay. So my answer is x equals 55. Okay. You know what I care about? I like the fact that you got x right. I care about the check. Okay? You need to work that check out, and when you get to a statement that's true, 3 equals 3, something that equals itself, and you know you've got the right value for x. So my answer is not 3 equals 3. My solution to this equation is x equals 55, because 55 is the only number I can stick in there for x that's going to make that equation true. And I proved it right here. Okay, you try. Okay, show me your brilliance. Make sure that check looks good, and I will see you at school.